Data warehouses were facing problems. We talked about those three problems, and we wanted a new technology or a new platform or a new approach to solve that problem. So data warehouses itself started coming up with the solution. And then there is a new platform which started coming up, which is called Hadoop, with a different approach to solve the same problem. The problem is variety, volume, and velocity. These three problems and all the requirements that were fulfilled by the data warehouses. All this was the requirement, right? We needed to have all the requirements that were fulfilled by the data warehouses, plus support the variety of data, support the volume of data in petabytes and maybe even beyond that. And we wanted a system which can support the velocity, support the real-time and near real-time kind of requirements. All that should be done. And at the time, maybe in year 2000 or late 90s, there were two approaches being approached. One we call monolithic approach. The other one is called distributed approach. Two thoughts. Monolithic approach was taken by data warehousing vendors, those systems that were offering data warehouses. So they took monolithic approach, and what they did is they scaled their system. They made their systems more powerful in terms of capacity and in terms of features. But then there was a distributed approach. They were trying to build a completely new system for that. So both the approaches were being evaluated on four main criteria. Right. The first criteria was scalability. Whether this approach or this approach, which one is more scalable. So monolithic approach were vertically scalable, and distributed approach were horizontally scalable. So what do we mean by vertically scalable? That means you keep on increasing the capacity of a single system. This is Teradata and this is Exadata. So what they did, they increased the capacity and power of a single system. Means in the single system, they added more CPUs, they added more memory, they added more disk. So you can store more data, you can process data faster, and you can do more with the same system, using the same system, and they increase the capacity. That was the vertical approach. Horizontal approach said that we increase the number of systems. We take a small system, start using that. That system comes with maybe some CPU cores, let's say 8 CPU cores or 16 CPU cores, some disk capacity and some memory capacity. Let's say 32 GB memory, 8 CPU cores, and 2 hard disks, which is each 2 terabytes, so 4 terabyte of capacity. You start working with that, and when you need more, you buy one more system and add it in your platform. You need more, buy one more system and add it into your new platform. You need more, buy one more system of a similar type and add it into your platform. So you keep on adding new systems. That is the horizontal scalability approach. As your requirement grows, you keep on adding more and more new systems, and this entire platform works like a single large system. Though we have small multiple systems, but this entire system, the entire group works like a single large system. That's what this distributed approach was trying to build. These guys were trying to offer that you need more capacity, you let us know and we will give you a bigger system. So that was the scalability. So on the scalability factor, businesses liked this approach more. They said, okay, fine. If I fill up this system at some point of time, maybe in 1 year, 2 years, or 3 years, then I'll have to buy a bigger system, which will cost me more. And maybe this system I'll have to retire, which is not useful for me now. But in this, if I fill up my capacity, then all I have to do is to buy some smaller systems and scale it. So existing system is also useful, and new system I can add it in small increments. I'll add one after 3 months. Maybe I'll add one more. Like that, I can go. So businesses liked horizontal scalability more. The second criteria they wanted to evaluate was the fault tolerance. So what happens if a machine fails, if a hardware fails? So in these large systems, if your motherboard failed of this system, this is all gone, right? So there is no fault tolerance in these systems. Your system is shut down, your business is stopped until that motherboard is replaced, right? So they didn't like that approach. But in these systems, they said, okay, if one machine in this group, because you are working in a group of machines, you build one system which is internally made up of a group of multiple systems, and the entire group works as a single large system. Even if one machine fails, motherboard of this machine failed, you don't need to worry, because the remaining 3 machines will keep running your operations, will keep running your business, and you have fault tolerance. Even if 2 system fails, your entire system will not go down. The remaining 2 make sure that your system keeps on running, and you will have time to replace these 2 faulty systems. So the fault tolerance is multifold in these systems. I mean, it can handle 2, 3, 4, 5 failures, right? So that is the other thing people liked about the distributed approach. The third criteria was high availability. So how these systems make my business keep on running forever, right, without having a downtime. Sometimes high availability and fault tolerance looks like a related thing. So fault tolerance and high availability are two different concepts. In the fault tolerance, what we try to understand is what happens if a component of my system is failed. Will my entire system go down, or will it keep on running? Will keep the problem hidden from the users and keep on running. That is what is called fault tolerance. So think of it like motherboard of this system failed, this entire system is down, my business is stopped. In this, if motherboard of this one machine failed, the entire system is not down, it's still three machines are working, so my business will keep on running. In both the approaches, we have a fault on the motherboard. This system could not avoid the fault, could not tolerate the fault. This system could avoid the fault, it's still running, it could tolerate the fault. So that is what we call fault tolerance. Fault tolerance is measured in the number of faults we can tolerate. So this system maybe can handle 3 faults if we have 4 machines here and we configured it to handle 3 faults. So the fault tolerance for this system is 3, fault tolerance for this system is 0. High availability is measured in terms of percentage of the system is running for the defined period of time. So how we measure the high availability? When we say high availability of this system is 99.9%. So what it means is in a year, 99.9% of the time this system keeps on running. There is this won't go down. 0.01% time it would be down. So if that time is like, let's say 100 seconds, high availability is 99%. That means out of 100 seconds, 1 second this system will be down, 99 seconds this system will be up, right? At the high availability is often calculated at the end of the period, mostly calculated on a yearly basis. So that's how high availability is different. High availability is a measure defined in terms of percentage, which tells what percentage of the time my system was up. Fault tolerance is measured in the number of failures that system has avoided or tolerated. So both are different concepts. So high availability for these were very high. Why? Because it could tolerate multiple faults. High availability for these systems was also high, but they couldn't tolerate too many failures. So there was a risk on the high availability. Solution for achieving more high availability on these systems was to build a primary and secondary. So you buy 2 systems here, make it primary. If motherboard of this fails, then secondary will take over and your business will keep on running. But that was very expensive. And this also high availability is maintained having a primary and secondary in some scenarios. If what happens if all 4 fails, right? So or what happens if this system is very critical, even these 3 fails, this one will keep on, the entire system will keep on working. But if this one is failed, then even the 3 is running and the system goes down. If that kind of problem is there, then how do we handle it? So for that there is a primary secondary approach where we make a copy of this system, keep 2 systems here. So and if one fails, the other one will take care of the job. So idea is high availability is always achieved through a backup system. Whether you take a monolithic approach or you take a distributed approach, in both high availability is achieved through a backup system, which is called secondary system. Both systems offered high availability using primary secondary, but cost of having a secondary on these monolithic approach was very high. Cost of having a secondary on distributed approach was extremely low. So businesses liked that also. The third was fourth option where or fourth criteria where they evaluated these 2 systems or these 2 approaches was cost effectiveness. So these systems were very expensive. These systems were economical. They needed you invest all the money at once. If you want to buy a system which can store 10 petabytes of data, you will have to invest all the money at once. But these systems allowed you to invest a little, then keep on adding more systems, more machines to your distributed cluster as your requirement grows. So they were more economical. So on all the 4 most critical business criteria, people found that distributed approach is much more better. And that's where distributed systems start evolving faster and businesses started adopting distributed system. And that distributed system at that time was Hadoop. And in simple terms, if you have to understand, if you don't know what is Hadoop, Hadoop is a distributed platform which offers you all the capabilities that data warehouses offered, plus solution for these 3 problems. You can handle variety of data, you can handle data at very high volume, and you can handle data at a high velocity. You can build streaming and near real-time streaming and batch all 3 types of systems on the Hadoop. And takes a distributed approach, and it also gives you everything that you had with the data warehouses. What are those capabilities? Data warehouses allowed us to store data. Hadoop system also allowed us to store data. They offered SQL query language to do the data processing. Hadoop system also offered SQL query language to do the data processing. They offered a scripting language, like for Oracle Exadata, we had PL SQL that was supported, or they also offered integration with some programming languages. So you can use Java or any other programming language to connect to the database over JDBC, ODBC connection and process the data using the language. But they gave you one inbuilt scripting language capability called PL SQL. Similarly, Teradata also gives you similar capabilities. So they give scripting language capability. So something which you cannot do using SQL, you have the scripting language with more flexibility to do your data processing. Hadoop also gave that. Programming language interface. So this system gave you feature to use programming language to connect these systems and do the data processing using programming language. Hadoop also gave you that capability. So just to quickly summarize, what I wanted to talk about here is in big data and data lake part, that in the past we were using data warehouses, which was great. We were living in the perfect world. But then growing adoption and usage of internet started putting up three main problems on the businesses, especially on the data warehouses. To support variety of data, structured, semi-structured, and unstructured, to support a huge volume of data in petabytes and exabytes, to support building streaming and near real-time streaming systems so that we can take decisions as quickly as possible, right? So the data warehouses at that time started failing to support this, and that's where new approaches were being evolved, evaluated. Two approaches came. One was monolithic approach taken by the same data warehouse vendors or data warehousing system providers. The distributed approach was taken by completely new approach, which was initially explained and published by Google and then adopted by open source community. And in this battle, distributed approach won. Because of these evolution criteria, business found distributed approach better, so they won the battle. On the other criteria, businesses found, okay, all the capabilities that I had in the data warehouses are still there. I'm not losing anything. I'm gaining new benefits. So they won. Distributed approach won. And the winner came out as something called Hadoop.